Sorry, sir. Very funny.
Okay.
And delivering the lecture for our ACT sponsored STTP. First of all, I thank you. Mr. Girish Kumar sir, please introduce to our today resource person, Dr. Kumaravel sir.
Yes, sir. Thank you. Good morning, sir. Kumaravel sir.
Morning, sir. Morning.
I'll start my introduction to the today's chief guest now. First of all, a warm welcome to all the participants. It's my great privilege in introducing our today's ACT sponsored STTP on recent development and entrepreneurship in sustainable green energy technologies and smart grids. Dr. Kumaravel Sundaramoorthy garu has been working as assistant professor in the Department of Electrical Engineering, National Institute of Technology, Calicut, since December 2018. He has acquired BE in Electrical Engineering from Bharati Dasan University, Tiruchirappalli, MTech in Power System from National Institute of Technology, Tiruchirappalli, and PhD in Electrical Engineering from National Institute of Technology, Calicut, Kerala. His thesis title is Hybrid Renewable Energy Systems for Microgrid Application. Also, he has completed postdoctoral fellowship in the area of power converter applications in power systems from University of Dublin, Ireland. His major areas of research are design and development of DC-DC converters, stability enhancement of microgrid, solid-state transformers, etc. As on July 2020, he has published 23 research papers in SCI journals, including 5 IEEE transitions and 4 papers in IEEE power electronics, and several papers in reputed IEEE international conferences held in India and abroad. He has supervised 5 PhDs and 30 MTech scholars. He has applied 2 patents, another in pipeline, in the area of non-isolated DC to DC converters. He has completed 2 sponsored research projects and involved in the development of real-time simulation lab and distributed generation lab in NIT Calicut campus. Currently, he has 2 ongoing projects with approximate cost of 75 lakhs from MEIT, CSIR and NAMPED 3. He has received awards such as Young Research Fellow from Ministry of Information Technology, Government of India, which includes the monthly fellowship of 20,000 rupees for 5 years. Young Scientist Award 2017 for Engineering Stream from KSCSTE, Government of Kerala. We also have the Outstanding Branch Counselor Award 2018 from IEEE Kerala Session. IEEE PES Chapter Outstanding Engineering Award also Sir has received. He is a senior member of IEEE, the member of ISTE and Institution of Engineering. Once again, I am thankful for Dr. Kumaravel Sundaramoorthy garu for today's speaker for AICT sponsored short-term training program. I'm very much thank you all participants also. So it's great pleasure for this opportunity. Thank you.
So, in fact, thank you very much, sir, for your nice introduction.
Thank you, sir.
Very good morning to all of you. I hope that you all are safe due to COVID-19 and they're doing safely in your home. So hope that the situation will be better soon. And in Kerala, it's a heavy rain now. So if there is any disconnectivity, please bear me. And kind request to the organizers, please check up whether I am in online sometime, because whenever we deliver lecture through online, whether it is tough to see whether we are in line or not. And since we concentrate in the presentation, like a monopoly, we run in one direction. Later, after some 5 minutes or 10 minutes, I may come to know that I am not in line. That happened naturally. So please remind me that whether I am in line or not. Okay, thank you, sir. Let us move towards the technical presentation of today morning session, hybrid renewable energy systems for microgrid application. So, though we have reached the modern technology today, just let me touch upon some fundamentals and the great innovations happens in the field of electrical engineering. So sometime it will help us. I think most of the participants may be directly or indirectly involved in research. So research itself a very good culture, but it's a recent culture in countries like India. Of course, 20 years back, when an engineering college is concerned, we are not doing either research.
Sir, your PPT is not visible, sir.
PPT is visible, sir? No.
Not visible, sir.
Not visible, sir. Kumaravel.
Yeah. Now, sir, now?
Yeah, share PPTs.
Also, it's not visible, sir. Kumaravel, sir. So, further on time to upload your PPT, sir.
Yeah. Now I think it is visible, right?
Yeah, now it's visible, sir.
It's visible.
So now am I audible and my PPTs are visible?
Yes, sir. It's audible and your PPT also is visible, sir. Thank you.
So when we see engineering education 20 years back, we most of the time we spend only in teaching, but now research become part of our profession. So we are in the position to pursue research also. Sometime looking into the fundamentals may give opportunity to start research in new direction. As a researcher, we know how to do research. Research topic may vary from time to time, place to place. So we should be ready to do research in any title. That is a present situation. Moreover, the competition also keep on increases, and at the same time, quality also significantly increased. The paper which they published 10 years before and now there are a lot of differences. If you try to take the same paper and upload it today, I don't think the success rate will be very less, because number of competition significantly increased at the same time quality also increased. So let us come back to the lecture.
Hello, sir. Kumaravel, sir.
Sir, Kumaravel, sir. Okay. Dear participants, please wait for 5 minutes. The sir will reconnect.
Sir, I think now I join back. Please give me permission to share my slide.
Sir, I will give the permission, sir. Sir, given the permission, sir. Kumaravel, sir.
Yeah. So, in his invention, he mentioned that lightning has enormous amount of energy. That was the invention made by Benjamin Franklin. Even today, there are a lot of research work is going on in the field of lightning. But though there are a huge amount of energy is available, we don't have technology to tap the energy to convert into useful form. Then Volta, I think after Benjamin Franklin, Volta come up with his galvanic cell. Then they were thinking that electricity means some kind of chemical medium, and the chemical reactions are taking place during charging, discharging. And that time the level of voltage was few volt and current was in terms of milliamperes. In fact, they are not dealing with any power devices during the time of Volta when he brought chemical cell. So later, Michael Faraday, who is called as father of electricity, really made a milestone in the field of electrical engineering by declaring Faraday's law of electromagnetic induction. So the experiment is shown in the slide. He used a primary winding and secondary winding, which resembles a transformer, but it is not in fact equally to a transformer, because the supply voltage is a DC source. So when he connected a DC source, he could succeed with the experiment. Usually when we ask Viva question to the student, when we supply DC to the transformer, what will happen to the transformer? So students used to say the transformer will burn. But if you see this experiment, in fact, Michael Faraday connected a battery. He succeeded, even though he connected a battery. Because there is a switch. He connected a battery through a switch. What is happening here? The circuit is completely intransient. The circuit is completely intransient. It means that the rate of change of current causes a rate of change of flux. When there is a rate of change of flux, again there is a rate of change of current. The whole experiment moves like this.
Sir, Kumaravel, sir, your voice is not audible.
Yeah, I'm getting, sir, I'm getting. The whole experiment is taking place like this. Something like he put a primary coil and a secondary coil. So he applied a voltage to the primary coil so that this is like an RL circuit, and there is a switch here, and there is a switch here. This switch is neither in closed position nor in open position. So the moment he closes the switch, the moment he closes the switch, the current rises from 0 and then reaches a finite value. And by the time he is opening the switch, so the current suddenly reaches 0. Then again he closes the switch, then open it. Then again he closes, then open it. So like this, he is making an experiment so that, as I said already, the circuit is completely in transient. The circuit is completely in transient. Whenever the voltage is applied, the inductor is charged so that the voltage will be always positive. And there will be a small amount of negative voltage, but it's like a pulse. It's a pulse because this is the time the charged inductor discharges the energy, short time, very short time. So it's like a pulse. So again, the voltage rise up, then continues here, and rise up, something like this. Some incident, some voltage arises across the inductor like this. So, but technically speaking, so V1 causes a rate of change of current dI1 by dt, and then this current causes a rate of change of flux, that is d5 by dt, because he is making a core like this and making a one winding here and another winding here. So this will be the direction of flux, or maybe in the other direction. This will be the direction of flux, which is decided by the direction of current. So that the rate of change of flux again causes a rate of change of current in the secondary winding, because the effect is reversible effect. So rate of change of current causes rate of change of flux, and that rate of change of flux causes a rate of change of current, and that causes a voltage V2. So technically speaking, V1, V2 without any physical connection, though it is a DC supply. So why I am particularly talking about this? Even today, people are pursuing research based on Faraday's law of electromagnetic induction. You know, only difference, Faraday considered that core, he experimented with the presence of core. Now it is in the absence of core. That is called wireless power transmission. I think all of you may talk about this wireless, no? So wireless power transmission. Even today, it is a big research topic, wireless power transmission. So in fact, we succeeded with wireless communication, but still we didn't succeed at large way in the power sector, especially in the wireless power transmission. I don't think this will be a permanent burden. Hope that this barrier will be broken within a short span of time. Why I am telling you, already some mobile phone companies, they launched already wireless charging. Just they are providing a plug platform like this, and over this platform they are keeping the mobile phone. That's it. Some mobile phone they are keeping and they are charging, right? So the distance between these two may be some micro meter, very small gap, but we are trying to enhance the gap in terms of meters. I think if the wireless power transfer succeeded with few meters, it will create a big revolution in the field of electrical engineering. So what I'm telling you, often rather looking into a latest technology, sometimes the old technology will give us new direction of research. Even in the year in 1805 or maybe 1810, Michael Faraday succeeded with his Faraday's law of magnetic induction successfully with the help of a battery and with the help of his own experiment. So next, after Michael Faraday, I already told that Alexander Volta come out with a chemical cell. Then after Michael Faraday, the great innovation made by Andre Marie Ampere based on Ampere circuit law. So Michael Faraday discovered that there is a link between electrical and magnetic. I think somebody is there in line. I do not know. Could you please mute? Yeah. Sir, I know somebody is in line that their mic is disturbing. I do not know whether it belongs to participants or audience. Yeah. So I will proceed further.
Yes,
So when Andre Marie Ampere discovered his circuit law, he went one step ahead compared to Michael Faraday. As I said, Michael Faraday correlated I think, am I audible?
Yes, sir.
Kumaravel sir, it's audible.
Yeah, okay, sir, okay. So when Michael Faraday correlated electricity in terms of magnetism, after that, Andre Marie Ampere correlated electricity, magnetism with the third field that is called mechanical. So Ampere circuit law states that when a current carrying conductor is placed in the magnetic field, then that current carrying conductor experiences a mechanical force. So he discovered Ampere circuit law called as F is equal to BIL, where F is the mechanical force, B is flux density, I is the current, and L is the length of the conductor. So that really made a great revolution in the field of electrical engineering. Why? He proved that huge amount of mechanical can be generated from electrical. Similarly, huge amount of electrical can be generated from mechanical through Fleming's Marie Ampere's principle. That is Ampere circuit law. Then slowly people started practicing generators, motors, and they built. Again, Michael Faraday contributed a lot to the field of electrical engineering. So they finally developed the generator as well as motor. So those days, steam engine very popular. Most of the application they used the steam engine, particularly in looming industries, and especially industrial revolution happened because of the invention of steam engine. And after that, parallelly electricity also started, and there was a tight competition between electricity and the steam engine. But later, when electricity become a transportation application, then they started using electricity in most of the application, especially looming industries, even marine engineering, variety of most of the industrial application, they started using motors as well as generators. So finally, they started the first electric power plant in the year 1882. Thomas Alva Edison in New York. So later he started the first hydroelectric power plant on Fox River, and this was the first electrical power plant started in India called as Sidra electric power plant in Darjeeling. So as I told, first power plant started in the year 1882, whereas in India, the first power plant started in the year 1897. There is a gap of 15 years. In that time, there was a great revolution happened between that AC. You could have noticed the first power plant started in the world by Thomas Alva Edison in terms of direct current. Whereas in India, we are seeing alternating current. So what happened in that 15 years? As I told, in the year 1882, Thomas Alva Edison started his own electrical company, Edison Company, and started generating electricity and serving to the customers. That was in terms of DC. Parallelly, our Tesla, that is called Nikola Tesla, he come out with alternating current concept. So he was demonstrating that alternating current can be step up and step down with the help of a transformer, so that we can serve electricity for several kilometers, so that alternating current is very good compared to direct current. So when he explained this concept to Thomas Alva Edison, he was not ready to accept. And then later, after working with Thomas Alva Edison for the period of 6 months, Nikola Tesla left Edison Company. And it was understood by the great person called George Westinghouse. And then he approached Nikola Tesla to establish alternating current based power plant. In fact, George Westinghouse and Nikola Tesla joined together and finally succeeded to make an alternating current power plant which serve electricity for several kilometers, where the Edison company transmit power only for few meters to 1 or 2 kilometers. You all know that generating electricity in terms of DC is very tough, especially when you go to high voltage, because commutation. Then stepping up, stepping down of DC voltage, these two main factors restrict the utilization of DC in those point of time. But whereas Edison company, whereas George Westinghouse, Nikola Tesla, when they come up with alternating current, later in 1887, finally the current war was won by alternating current. Then 1887 onwards, generation, transmission, distribution, utilization, everything was completely rolled by alternating current. That was the great situation till some point of time, especially after utilization of electronic components. In the year 1950 onwards, full swing research happened in the field of electronics. They invented transistors, then later power electronic devices like thyristors. All sort of power electronic components started utilizing in computer and other that's something called the SMPS, UPS. Those applications started full swing at the end of the 20th century. Then now if you ask a question whether AC is superior or DC is superior, you don't have a unique answer, because both of them are essential as a consumer is concerned. Because alternating current, in fact, it is good, but you can't store electricity in the form of AC, because average power of a cycle is 0. We can't store AC. Since there is no comfortable source in alternating current, we are moving to direct current. That's it. Direct current can be stored in terms of battery or maybe other devices like ultra capacitors and SMES. There are some devices coming up, and these devices, particularly battery, given attraction towards direct current, especially most of the application we are using portable applications. So that direct current is essential at present. So now you all know that direct current joined along with alternating current and now combinedly called as a hybrid system in any power system network. It may be a generation, maybe a transmission, or maybe of course distribution. Currently we have only AC. Maybe later when the microgrids and all coming up, we will go to DC distribution also. Already you all know that transmission become HVDC. HVDC popular especially for the past 20 years. Generation also main revamp happened after the invention of solar photovoltaic. Though it is generating DC, now started in terms of megawatt. There are several 200 megawatt power plants and all government started in terms of DC. So as I said, DC source already arrived, DC transmission already arrived. Distribution, of course, we follow AC currently. But utilization point of view, most of the applications we have DC, like LED lamps and in fact BLDC motor. There are most of the applications we started using DC. So now if you ask a question, AC is superior or DC is superior, we don't have unique answer. So we have to use both AC as well as DC. So another main development happened in the field of renewable energy, especially for the past 30-40 years. Though we have some resources in terms of conventional, right, like fossil fuel based, like coal, oil, or something like atomic power plant or hydroelectric power plant. So they are limited in nature. All the fossil fuels, especially conventional resources, they are limited in nature. So there are a lot of technical and social issues are there related to the utilization of energy from conventional energy resources. You all know that global warming become one of the major issues. So we are moving towards renewable energy sources. So though there are different forms of renewable energy sources, solar PV and wind, both of them are taking lead, and most of the customers, they started generating electricity using their own There are some industries, they are generating electricity using windmills, maybe low capacity like 100 kilowatt, 100 kilowatt wind turbines. They started generating them. So hope that there are some more renewable energy sources are yet to join with us. Hope that in near future they also will join and make renewable energy will be our future need. So at the earliest, when we are moving from conventional resources to non-conventional energy resources, we are not in the position to use conventional grid. That's what I put macro grid to micro grid. I think you all know what is called a macro grid. So when we talk about a macro grid, in the case of macro grid, there will be a source. For example, if you see our macro grid, you will have thermal power plant. For example, assume that this is your thermal power plant, and the capacity may be several megawatt. Assume that 200 megawatt, and this there will be a transformer. So naturally we generate power using 11 kilovolt, and then we convert into 110 or maybe 220 according to the availability of grid, and then we are connecting to a very big network. Assume that this is your very big network. Assume that this is your big network, And this is a thermal, this is your centralized network, which is transmitted from Kashmir to Kanyakumari. There's a central pool, there's a network, very big network. So this is from one place. Similarly, there may be another generator and they may connect another distribution, that substation transformer of the same 110 or maybe several voltage we may follow. This may be hydro. This may be hydro. Like that, there are everywhere sources. Everywhere sources. Many places we are integrating. Everywhere sources. At the same time, we are tapping energy from here, and we use again a step down transformer. Then we are feeding to a load through a proper distribution system. Through a proper distribution system. Everywhere in the network, there are loads. So when you see this is called your grid. This is called your grid. And this is called macro grid. This is called macro grid. So when you see the distance of this macro grid may be several kilometers, maybe several 100 kilometers. And the level of voltage may be 110 kilovolt or maybe 220 kilovolt or maybe 440 kilovolt. According to the level of transmission, they decide the voltage. So capacity of that may be 1000 MVA, 1000 MVA or maybe 200 MVA. So the capacity of transmission line varies according to the power transfer or maybe availability. And all these things are tie lines. And most of the time, when you see the nature of the macro grid, will be a ring main system, Of course, we follow distribution as a radial system even today, but that centralized system is our ring main system. So, if you see what is the role of the grid here, this grid integrate large amount of sources as well as large amount of loads, and that network is called as a grid. And here what is happening? Load takes its own real power and reactive power. So always in the load, real power and the reactive power keep on varies with respect to time, because nowhere the load is constant. 12 o'clock there are nature of load, and 1 o'clock different nature of load. Maybe real power, reactive power will never be constant. So when these two changes automatically, there are two parameters we are regulating. One is called the voltage and another one is called the frequency. So naturally we control frequency in the thermal power plant or maybe hydro power plant with the help of AGC. I think all of you may be aware about AGC, automatic generation control. We always regulate the frequency because we have a regulation, maybe something like F minimum and then F maximum. According to the power, I'm telling. So the way how we regulate frequency in thermal power plant may not be the same in hydro power plant. Even it may be decided based on the capacity sometime. So one end, according to the variation of real power and the reactive power, we are regulating frequency, and we regulate the voltage also. Voltage also have the lower margin and the margin like lower value and the higher value. And that naturally we have here called as AVR, automatic voltage restorer. And in the transmission system, we have our OLTC. I think all of you may know about OLTC, on-line tap changing transformers. So we use tappers to control the voltage, so that we are controlling the voltage and the frequency in a permissible limit. So that maintains stability of the whole power system. So whenever I am talking about all those things, the term stability is coming to the picture. Stability. So whatever I am explaining so far, that is the concept of macro grid. There is a concept of macro grid. So grid is nothing but the duty of the grid is to integrate source and load. That's it. The duty of the grid is to integrate source and load. In outset, if you see, there is a source and there is a load. That's it. And this portion is called as grid. This portion is called as grid. And whereas in the macro grid, source is in one end, load is in the other end. But whereas when you come to the concept of microgrid, whereas if you come to the concept of microgrid, what is taking place is completely different. So when you see in the concept of microgrid, for example, if you have a solar panel, so you have a solar panel here, and this panel is connected to a small DC-DC converter, or sometimes directly we fed into DC to AC inverter, and then we connect to a load. And we have, in apart from the load, we may have a grid here. We may have a grid here through some connection. Some breaking will be there, so that it will help us to make power transfer from load to grid. So this is your grid. So sometime you may have one more source here, you may have one more source here, or maybe sometime we may club this with a battery here, and there may be a battery through a DC-DC converter, and you may have a battery here. So when you see here, there is a small network arises. There is a small network arises. This is nothing but source, and these are loads. As I already pointed out, a network which connect sources and load, and this is called a grid. This will be done by grid. Why? Because here real power changes, reactive power changes, and but in fact the total system is available locally here. The total system is available locally. This is called a local system, where there is a source and there is a load, but there should be a grid. Why you should have a grid? Because real power, reactive power changes, you have to regulate voltage and frequency. Assume that it is not connected to the grid. It is not connected to the grid. Even if it is connected to the grid, we are regulating. I will come to that later. That is called a grid connected mode. Assume that time being the grid is open, and here it is in the autonomous mode, in the local mode. What I am commenting here, there are sources, there are loads, and we have to follow grid profile. We have to follow grid codes. And that grid is. So why it is called as a microgrid? Because small sources. Why? This may be few kilowatt, maybe 10 kilowatt, and your load also according to that. So everything is lower in scale. Small source, here small source, here small load. So the grid also small. So we are calling this a microgrid. So whatever we do in macro grid, same process we have to follow in the microgrid. I think all of you may agree with me. Source is always a source. Doesn't matter, it may be a 10 kilowatt or maybe a 10 megawatt. There is no difference. Because we have to regulate your voltage, we have to regulate your frequency. Why I am telling you, source load varies in its own way. So the total local system should be treated as a grid, and that grid is called a microgrid. I think now it is clear to all now what is the difference between macro grid and the microgrid. So when you try to go to the concept of macro grid and microgrid, it always looks like this. In fact, so when you see your microgrid, it is looking like this now. So conventionally, there is no source here, no battery, no wind. But at present, every customer, they started using solar PV, battery, in everything locally so that so whenever you take the local sources, the total grid will be looking like this. That is called a microgrid structure. So when I said microgrid, it's a new concept. Even today, lot of research work is going on, especially in the stability point of view. Why stability point of view? The total microgrid structure is called as a weak grid. It is not like your conventional macro grid. Why it is called as a weak grid? Because the X by R ratio is very high. Whereas the total network is resistive in nature comparing to the inductance and capacitance, because it's a short distance line and moreover lower voltage, 400 volt short line, so that the value of X by R is very, very high. Whereas in the case of your conventional macro grid, there the X by R ratio is very, very less. The X by R ratio is very, very less. So whenever there are reactants, they are giving some kind of support. But whereas that is missing in the short distribution system, which is going to called as a microgrid. And moreover, here the sources are highly intermittent in nature. Solar PV, wind, all these things are highly intermittent in nature. And when you try to see the circuit breaker, when the circuit breaker is closed, it will operate in the grid connected mode, so that your solar PV, wind, everything will operate in MPPT. That is called maximum power point tracking. You all know that. So when it is operating in MPPT, maximum power point tracking, solar PV will inject in its maximum capacity. So for example, if you have 10 kilowatt solar panel, in daytime at 12 o'clock, the same 10 kilowatt can inject 12 kilowatt or 13 kilowatt power. That is a unique difference in renewable energy sources. Suppose if you have your conventional generator of 100 megawatt capacity, the maximum power it can give only 100 megawatt capacity. But whereas solar PV, the rating is 100 kilowatt or 100 megawatt, but it always generate more than that sometime. And even sometime it may be lesser than that. If you take output power of a solar panel of a 10 kilowatt, it will vary throughout the day, especially morning 9 o'clock, then there's a peak in the afternoon, then comes down, then no availability in the night, or maybe meager availability in the night. So such a dynamic nature of renewable energy source is going to create a great instability problem. So if you are a researcher, you can do research in terms of an instability approach of microgrid. There are a lot of work is going on, how to improve stability of the microgrid. Second one, when we talk about the reactive power management, so far there is no custom power devices available in the consumer end. So consumer have only loads, but now they have sources. When they have sources, who is going to contribute the reactive power? That's a question mark. So because every customer, they are trying to inject real power, but they never talk about the reactive power. So now I am telling you what type of policy can make attraction. So I am telling policy aspect. Lot of research work going on in the aspect of framing policies for microgrid. So I already told stability aspect of microgrid is one type of research. Now policy aspect, another research is going on. So how to make the tariff structure, and what are the terms we can define. For example, terms like SCI fee, CAI fee, there are a lot of terms are coming up. then penetration of renewable index. Then there are some kind of index and all coming up, right? I think you all might be aware about all such new terminology. So electricity price will be fixed not only based on the energy, different factors will involve in that. So now, in fact, we pay electricity based on the energy consumption. We never worry about your real power. You never worry about your voltage frequency. But whereas in the near future, entire thing will revamp into a new structure, new tariff structure. I'm speaking tariff structure. Maybe THD will be accounted, and reliability will be accounted, and so many factors will come to the picture, especially energy policy is concerned. So that aspect, lot of research work is going on. Then here there are some fixed sources, there are mobility sources. And you can think what is called a mobility sources, right? Your battery will be called as a mobility sources in the near future. Why? Because lot of electric vehicles are going to come. So when you see the capacity of battery which we currently use in our home for UPS is lesser in capacity. Hardly 100 maybe AH. I think all of you may be using battery in your home, especially for UPS. So the capacity of battery hardly 100 AH, 12 volt 100 AH. So with the help of that small battery, you can power up 2 lamps or 3 lamps and 1 or 2 fans, maybe for 12 hours. So I am telling you, with the help of 100 AH battery, if you manage your home, our electric vehicle will be a big resource in the near future. So why I am telling you, if you try to have a 100 and 1200 cc a diesel car, that is very popular in India, especially countries like India. So when you try to replace 1200 cc IC engine by an electric motor, approximately you need 30 kilowatt power. Approximately you need 30 kilowatt power. So if you want to power this 30 kilowatt motor, what is the size of the battery? If you power up for 2 hours or 3 hours, assume that you are powering up 3 hours. I think you can do a simple calculation, right? So that it will give some attraction towards that direction, right? So when you see battery of 1200 cc, so what I am telling, if you have 1200 cc, so the approximate capacity in the motor is 30 kilowatt. Assume that you are riding 3 hours in a day, so you can put 30 kilowatt into 3, so it is going to be 90 kilowatt hour. 90 kilowatt hour. So assume that ideally you are using a 12 volt battery. Assume that you are using a 12 volt battery. So it will become 90,000 by 12 volt is 7,500 AH. So we have hardly 100 AH battery. We have hardly 100 AH battery in our home. Assume that. So 75 times greater. 75 times greater, right? So can you imagine how much resource we are going to keep in the car? How much amount of resource we are going to keep it in the car? That's what I said. Mobility source. our car is a mobile source. So sometime it may be in your home, sometime it may be in your office, sometime maybe in shopping mall. But everywhere if you go, there are electric network. So how can we utilize or make use of such a massive capacity battery? And when you try to integrate with grid, it is not a easy task. It is not a easy task. Why I am telling you? Now we go back to that network. So it is very tough, especially when you see the point of connection. Why I am telling you this point of connection? That is going to decide the losses of the total network. If you connect your car here, one type of loss. If you connect your car in the end, another type of loss. In fact, lot of research work going on. Where can you charge your car? In which point you can charge your car so that the losses will be less? I think now you may understand. So that itself become a big research today. That is nothing but distribution loss reduction problem. So how to reduce your distribution loss by locating the optimal position for charging your car. That itself is an optimization problem. So like that, there are plenty of research work going on in the microgrid. Stability aspect, another one I am telling you, maybe the power quality aspect, and third one I am telling you energy policy aspect. Now I am telling you power system aspect, means economic dispatch or load unit commitment, loss reduction. These aspect, the research is going on in multi-dimensional way. So according to your interest, you can select your research topic, then you can proceed further. So when we talk about energy sources, as I pointed out, two resources are playing major role. One is your solar energy. So ultimately, sun is our primary energy source, and all remaining forms of energy are indirectly coming out from sun. So solar energy is the primary form of energy. So when you see solar PV, in fact, Albert Einstein discovered the concept of solar electric effect, solar photovoltaic effect. Albert Einstein is a great scientist, contributed a lot of things, but in particular, his contribution of the solar photovoltaic effect made a great revolution in the field of communication, especially satellite. Because in satellites, the primary resource is solar energy. So in fact, the invention made by Albert Einstein made a great revolution in the modern society. So for that, Albert Einstein received a Nobel Prize for the invention of solar photovoltaic effect, telling that electricity can be generated from sunlight. That is the photons. That's what his invention. So solar photovoltaic cell is nothing but a light consuming diode. It's a reverse process of LED. So solar PV is a PN junction diode. So there is a P layer and there is a N layer. And when light falls on the electrons, then the electrons are accelerated. So then it moves from valence band to the conduction band. After moving from valence band to the conduction band, we are allowing to flow through the load. So that's how the solar photovoltaic effect work. Technically speaking, this is your valence band and this is your conduction band. And there is a gap exists between these two, so this is your electron. So when sunlight, there is nothing but photon, which is nothing but packet of energy strikes your free electrons so that it moves from valence band to the conduction band. Due to a small potential difference, the electrons available in the conduction band goes to the load and then loses the energy, then comes back to the valence band. That's how the total circulating current happens in solar PV cell. So whenever we talk about the solar PV cell, all of you may be knowing that solar cell is approximated as a current source. So when you have a solar PV system, it is approximated like this. There is a current source, and this current is called as light current. And then there is a diode effect, and there is a diode effect. So we are putting a diode here. And this is called a diode current. And then you have a load here. And here we have a load here. This is called a load current. This is called your load current. And here we are connecting the load. So the voltage, whatever we across here, is called as PV voltage. This is the equivalent circuit of, ideal equivalent circuit of a solar PV panel. So when you see the characteristics of the voltage and the current, it is like this. The maximum voltage is called open circuit voltage, and this is called short circuit current, and the solar operating region is like this. Like this. Okay. So here somewhere there is a maximum power point, and what is the beauty here? This region operates as a current source. This region, it operates as a constant current source. Constant current source. But whereas in this region, some extent the voltage is constant, right? In this region, voltage is constant. Because though the current changes, voltage is almost constant in this region. So here we can say that, but comparing to this region is very narrow. So we can't approximate as a constant voltage region, but some extent it's a narrowing voltage region, right? This region I'm talking. So we always try to operate in this region. We never operate in this region, but there are possibilities. I'm telling there are possibilities, but because we always move this direction. But what I'm concluding here, so when you see here, this is your positive and this is your negative, and you have a diode. Now you can tell me whether the diode is in the forward bias or in the reverse bias. The diode is in the forward biased condition or in the reversed biased condition. So any answer from the participants? So am I audible first of all?
It's audible, sir.
Yeah, it's a forward biased condition. So my question, when the diode is in forward biased condition, this path should behave like a short circuit path, no? This path should behave like a short circuit path. So whatever the light current in the short circuit condition, IL should be equal to ID, right? Because it's a short circuit, because forward path is nothing but short circuit. That's what we understood. But if it is a short circuited condition, how do you get light current or load current? So here, this is not only diode current plus load current. So my question here is, when the diode is in forward biased condition, how do you get this load current? Because this diode current is restricted by the saturation current. When you see this ID will be the function of I0 into exponential, some term will come here in terms of voltage. So this current is called the saturation, forward saturation current of the diode. So you have by default load current. So that is called recombination. For example, assume that you have the PN junction like this. You all know what is a PN junction. Assume that this is your P layer and this is your N layer. And you all know that here the holes are the majority carriers, and this side the electrons are the majority carriers. This side negative electrons are the majority carriers. And there is a barrier potential. You all know that near the junction there is a barrier, right? Near the junction there is a barrier. So in this situation, when light fall on this light creates an electron hole pair. I'm telling you, electron hole pair. So positive and negative created because of this light. Sometime this positive negative creates a potential to go through the load. For example, assume that this is your PN junction diode and this is your load. Sometime the created electron hole pair, whatever the electron hole pair created, makes the current here and it is doing some useful work. But whereas sometime whatever the electron hole pair created, that recombine here itself. Create here itself. And that recombination losses is major loss of diode, which is degrading the overall efficiency of the solar cell. Right? So whatever for example, assume that 100% electron hole pair created because of this light current, all the 100% electron hole pair will never go to the load. Only some 60% or 40% according to the material, the only few percentage goes to the load, that is in the useful manner. The rest of the electron hole pairs recombine here itself and dissipated energy in terms of heat here itself. And that is the reason why solar cell temperature increases. You all know that solar cell is concerned, temperature is a sensitive factor. For example, if you have your power curve like this, ideally, you all know what is called a standard test condition. Assume that this is your solar panel, this is your voltage, and this is your power. In ideally, it is like this at 25 degrees centigrade. Whereas when the temperature increases, this power drastically comes down. You all know that. So even this power may be half. So assume that this is producing some 50 watt here, and whereas here it can go to 25 watt when the temperature goes from 25 degrees centigrade to 75 degrees centigrade. So temperature is one of the major sensitivity factor. I think a solar cell is concerned. There are 3 generations we followed now. So the first generation based on the amorphous, maybe that silicon material based, where the efficiency is low and the cost is high. Whereas in the second, efficiency remaining low, but the cost become low. Right? That's what we use today. 20 years back, when you see the cost of solar panel, maybe 1.5 lakh or maybe nearly 2 lakh per kilowatt. I'm telling only panel cost. But today, 1 kilowatt approximately cost around 20,000 rupees. You can see the cost of the solar panel drastically comes down in the past 20 years. But at the same time, efficiency is remaining same. Olden days, the efficiency was something like 18% or 16%. But even today, the efficiency is remaining 12% or 14%. Sir, shall we have a break of some 10 minutes?
Sure, sir. We'll continue. Sir, we'll start 11:20.
Yes, sir. We can start by 11:20.
Okay, sir. Dear participants, the 10 minutes for this tea break. So all are get connected with Microsoft Teams link, the same link for 11:20.
positioned from the sun, that we don't burn and don't turn to ice. The real problem is not deforestation, not global warming, not pollution. It is us ignoring the future. For a better tomorrow, BVRIT found a way to save energy, fuel, CO2 and green by using solar energy. This will have its impact on their generations to come. Remember, we only have one home.
Yes, yes.
Sir, I could not share the PPT. May I know the reason?
No, sir. Wait, sir. Sir, 1 minute, sir. I will already given.
Yeah. Now can you see my PPT, sir?
Yes, sir. It's visible, sir. Peak point power tracking. PowerPoint tracking.
Yeah.
Sir, it's visible. It's welcome back. The session, sir. Sir, Kumaravel, sir.
So welcome back.
Thank you, sir.
Yeah. So we were talking about the power generation from solar photovoltaic. So what I am highlighting here, this solar PV is a dynamic source. So we need a support from power converter. So our solar PV will be fulfilled only when you have your that solar the power converter. So what I am conveying here, if you have your solar PV, assume that this is your solar PV. So here you can have your DC converter, and then either we go for a storage here or maybe a load. This may be go to a battery. You can have a battery here, and here it may go to another converter called as inverter. So this is DC to AC converter, and then we go for grid. And here also there is a difference. And here either you can go to a local load or a grid through a breaker. So this will be your utility grid. This will be your grid. This is the total solar PV based energy system. So here you can see these power electronics are going to play a major role. And apart from that, a total control system. Here we need a proper control system, right? Without this control system, nothing can be operated in this system, right? Because solar PV instantaneously varies. And when you see here, local sources, and you have PPV, let me call it as PPV, and you have a P battery. See, P battery is concerned, it may be plus or minus. I think you may know why I am putting plus or minus. Sometimes power may be drawn by the battery, sometimes injected by the battery. So I am putting plus or minus PB. And grid, you have a grid, and grid also plus or minus P grid. Why I am telling, when the breaker is closed, the power either can go to grid and can come from grid. So the total balance, what I am telling, PPV plus or minus P battery plus or minus P grid is going to decide your load power. So here everything is dynamic. The total system is dynamic. So without the control system, nothing can be operated. So even today, there are a lot of research work is going on in the control system aspect. And moreover, PPV, P battery, what is the amount of power to be injected? A, B, because A is not constant, it is also varying. Accordingly, you have to control B. So, lot of a new research work coming up based on the power management of microgrid. Then apart from the control system, power converter. Of course, I am doing research in NIT Calicut based on the power converter, and whatever the IEEE transaction which we published recently in industrial electronics and circuits and system based on a DC-DC converter. So we are actively doing research in this portion. We are actively doing research in this portion. So even today, there are a lot of research scope available in the DC-DC converter. In fact, I myself have done part of my work, PhD work in the DC-DC converter, and my first student already completed PhD in the DC-DC converter. My second student also completed in the same area in the DC-DC converter, and now final student, third student is submitting thesis in same area. I'm telling DC-DC converter. So I have started in the buck boost converter in the year 2009, and gradually I acquired various information, and finally during my PhD, unfortunately I could not succeed with the IEEE transaction, but my first student, when he done work, we come out with the first transaction in IEEE transaction on industrial application. And my second student, in fact, he published several IEEE transactions, including IEEE transaction in industrial electronics. Then circuits and system, we got the 2 papers. Like that, now we succeeded, especially in one area. So what information I want to share with you all, whichever domain you are comfortable, please take that domain and stay in that domain for a long period of time. So initial stage, definitely we can't succeed. Maybe one day, 1 year or 2 years, I don't think you can't succeed because tight competition. When I sent my first paper in the year 2009 to IEEE transaction on smart grid, a very big comment received more than 4 pages. And I really afraid the paper was rejected, but even then many comments they have given. Then I afraid to submit back to IEEE. Then finally that paper was succeeded in IEEE in Taylor and Francis in energy source, electric power components and systems. So later my attitude changed. We tried only in IEEE. That's how the first paper we got in IEEE transaction on industrial application. So I'm telling you, getting a standard publication may be delayed, but nowhere it will be denied. But we should have a patience. At the same time, you have to understand the grassroots level problem, because the level of reviewer, the standard of reviewer will vary from journal to journal. And that too, I wonder, whenever you submit a paper to IEEE transaction for the matter of 8 pages, these reviewers, sometime maybe 3 reviewers, sometime maybe 5 reviewers, these reviewers are coming out with 1 page of comment each. Hardly total size of the paper is 8 pages, more than that. I really wonder how these researchers are understanding our paper within a matter of 2 months of time and coming out with this much comments. But I'm telling you, most of the time the comments are very correct and moreover genuine also. I really appreciate the reviewers' effort, especially in the standard publications. So only when you communicate your paper to standard publication, you can really understand where you are standing. I'm telling you, don't worry about the failure are nature in research. Sometime you may get failure, but doesn't matter, you will get failure always. Definitely when there is a failure, next moment you can succeed. By keeping that in your mind, you can proceed so that you can succeed. 1 minute, please. So what I am suggesting, selecting research area is the main thing as a researcher is concerned. Whenever you start a research area, you need not worry about so many things. What will be the control? What will be the system? So many things. You need not worry about that. First of all, you have to do the analysis on the research title. Which are the latest paper coming up in according to your area. For example, when you say in my research power electronics, I will strictly update some 4 journals. One is IEEE transaction on industrial electronics, IEEE transaction on power electronics, IEEE journal of emerging and selected topics in power electronics, IET power electronics. These are the 4 leading journals I always refer to conduct literature. And that too, person specific. You may wonder why I am talking about the person. Because whenever you write a paper, you should know who will be your reviewer. I can pinpoint various people who are going to review my paper, because they naturally, who will be my reviewer? The one who published similar work. I can count a number of people who are doing great work in my field. So like that, you have to pinpoint the reviewers, because they references, because by default IEEE will select reviewers based on the references whatever you cite. So you should be very careful in writing the paper and citing the paper, because
Hello, sir.
Yeah.
Sir, presentation is not visible, sir.
Yeah, I will come to that, sir. I think that slide sharing, I do not know what happened. I will share once again. Yeah. So sometime I may be deviating from the subject. I am talking generally. Is it okay, or I can stick on only on technical content?
No, sir, it's okay, sir. It's having, I think it's many of the participants are registering PhD or verging to complete PhD. Surely this information very helpful for our participants. Hello, sir.
Not clear, sir.
Sir, I think many of the participants are faculty members. They are registering his PhD or verging to complete his PhD. Surely this type of information helpful for the participants. You continue this, sir.
Sorry, the voice is breaking. I do not know whether problem from my side or from your side.
Sir, you continue, sir. It's no problem, sir. You continue. It's
Okay.
generating source. It's no problem. So why is okay?
Okay, no problem. I will proceed further. So when we talk about this MBPT tracking, as I already shared my slide on the maximum power point tracking. So most of the time in maximum power point tracking, we depends upon converters. We depends upon power electronics. Now I am bringing another dimension of research in power electronics based power system research. So power electronic nowadays cannot be isolated because everywhere these power electronics are playing a crucial role. Not only in solar PV I am speaking. If you take a battery, there is a power electronics. If fuel cell, there is a power electronics. Even otherwise, UPS, there is a power electronics. Everywhere these power electronics are playing a major role. So, as I said, the technological development happened in the sources side. As I pointed out, solar PV and wind, everywhere, all these renewable energy sources booming up like anything. And most of the consumers, they have battery with them. They started installing solar PV. There may not be any wonder in near future, fuel cell also will join with us. So when you talk about a fuel cell, which is electrochemical devices, and there are different types of fuel cells. You all know that hydrogen fuel cell is very popular, but nowadays people are concentrating on hydrocarbon based fuel cell, that generating electricity from something like a methane, that the family of hydrocarbon gases, because maybe due to biodegradation, every customer can generate carbon, that's hydrocarbon gases. I think some of them, they have already biomass planned in their home as a part of gas generation utilizing for kitchen applications, especially for cooking applications. So rather than utilizing that gobar gas or maybe some type of hydrocarbons, for heat application, if you have a fuel cell, you can inject that hydrocarbons and you can generate electricity. That direction now research is going on. Hope that in near future, fuel cell also will added with our electrical sector. There are a lot of advantages because electricity can be generated directly from methane or ethane, some hydrocarbons, static device. Yeah, clean, quiet, and highly efficient. And rather than burning, if you produce electricity, efficiency can be improved 2 to 3 times. So, main thing, something like this. This is the operation of a fuel cell. This is hydrogen fuel cell. I am explaining the operation of a hydrogen fuel cell. So there is an like our battery, there is an and cathode. There is a proton exchange membrane. And one end we supply hydrogen, other end we supply oxygen. So at the moment when hydrogen enter, that proton exchange membrane isolate protons and electrons. You all know hydrogen is the first element in our atomic table. It has a molecule. So has 2 electrons. So after losing 2 electrons, and the hydrogen proton moves from here, and in the anode side and the cathode side, that proton and the energy lost electron joined here with oxygen and produce water. So this process produces electricity, so that this will be our future technology. Instead of using hydrogen as a fuel, now they are making attempts towards hydrocarbons. Hope that in the near future they will succeed. The main lot of technical challenges they are facing today. That is the reason even now it is not commercialized. There are some fuel cell available for research purpose, but they are very costly. So this is the 1 kilowatt fuel cell setup we are having in our NIT Calicut. So main advantage why we are moving towards a fuel cell, like your battery, it can use it as a storage device. Whenever you need energy, it can act as a generator. Whenever you have surplus energy, it can act as storage, like a battery. So, like your battery, it stores energy in terms of chemical medium, especially through ions, charging, oxidation, oxygen reduction takes place during charging and discharging process. Whereas limited cycle, that makes limiting in terms of a cycle. In fact, we succeeded a lot in the case of a lithium-ion battery compared to lead-acid battery. Efficiency-wise, performance-wise, size-wise, and weight-wise, lithium-ion battery is better than classical lead-acid battery. I hope rather storing energy in terms of a chemical medium like a battery, if you go to a fuel cell, fuel alone can be separated from the stack and it can be sell as a fuel. However, we sell our cooking gas cylinder, you can sell fuels. That type of situation will come definitely in the near future, so that energy, anybody can generate energy, so that it can be sold like a commodity in the market. That type of technology is coming up in the near future. So, wherever you go to fuel cell or battery, we always need a support, because primarily fuel cell and battery, they are not directly from electrical, they are from chemical. So, whenever you go to energy conversion from chemical to electrical, they have their own time constant limitations, so that you always need a support. So there, our ultra capacitor play a major role in the support of battery as well as fuel cell. So you all know ultra capacitor, it is called as double layer capacitor, something like a 2500 farad capacitor and all available in the market. Almost technology is available today. Hope that the size of the battery, size of the ultra capacitor and the cost also will come down in the near future. So what I am finally concluding, without power electronics, we can't construct any power system today. It may be a micro level or maybe in the macro level. So these power electronics by default become integral part of our system. So when we go to a DC converter, especially there are two types of DC converter. One belongs to isolated category, another one belongs to non-isolated category. Of course, I am doing research in non-isolated category much. There are a lot of advantages of non-isolated category because it contains zero leakage current. So you all know what is called a leakage current. If you have a transformer, by default there is a leakage current which degrades the performance, and sometimes the switches get damaged. But whereas in our non-isolated category, you can have zero leakage current, but there are some drawbacks. So even though you go for non-isolated, there are some drawbacks because of surges. Whenever it is a grid connected system, surges cannot be avoided. The moment when there is a surge in the load side, by default it propagates in the load side, so that source may damage due to the surge. That is a major drawback when the non-isolated converters are concerned. And main thing is these non-isolated are very compact, sometimes light in weight. So best example is a buck converter. Buck converter is the best example of a non-isolated DC-DC converter. So wherever you go for a converter, by default there is a controller. So understanding of the system is most essential here to design a controller. So this is an example of an isolated DC-DC converter. You can see that there is an isolation provided with the help of a high frequency transformer. In fact, we are moving from line frequency to high frequency. Nowadays, we never go for 50 Hertz. Why? 50 Hertz transformers are bulk in size, consume more volume of copper. Sometimes we face problem in transportation. You all know that the size of a 200 megawatt transformer very large in size. So rather than operating at 50 Hertz, if you go to high frequency such as 100 kilohertz or maybe 200 kilohertz, the size of the transformer can bring down significantly. So that is the reason why we go for isolated high frequency DC-DC converter. Though it is called as a DC-DC converter, it is still AC only. So this input is DC, output is DC. That's why we call it as a DC-DC converter. But originally speaking, DC is converted into high frequency AC, and here there is a coupled in transformer. Again, a high frequency AC converted into DC. That's how that whole system operates. And this is the best example of an isolated DC-DC converter. And this transformer provides a galvanic isolation. Some application, galvanic isolation is recommended as per the standard I speak. So at the earliest, whenever we see our students, how they are performing research, they take some circuit from IEEE transaction, they do some simulation in MATLAB. After doing simulation in MATLAB, they get some result, and with the help of that result, they publish papers. So in my point of view, there is no meaning in maybe putting that type of publication. So when you see naturally what is going on in most of the student cases, so what they do, they take a circuit from IEEE transaction. So they take a circuit, and sometimes they understand the operating principle and other things. Sometimes they neglect that, and directly they go to simulation. Maybe some packages like MATLAB or maybe PSCAD, some type of simulation they are doing. Means the circuit they will arrange using some block sets, some library, right? Whatever the ready-made library available, they take some switch, source, inductor, capacitor, drag everything into a platform, and they connect everything like a circuit, and then they do simulation and they get some waveform. And after getting the output in terms of some waveforms, and directly they start writing paper, right? So what I am telling you here, there are a lot of problems. This is not the correct research. If you see even most of the papers published in IEEE conference, they follow this passion, right? That is actually, there is not correct. There is no use of these type of papers. Even sometimes number of paper count will increase, but absolutely there is no use of these type of research. So what we usually we are expected to do, the moment when you understand the circuit, doesn't matter, you can take IEEE circuit, okay, whatever the circuit they publish, you can take it, there is no mistake in that. The moment when you take the circuit, you can split into two types. One is steady state analysis, and another one dynamic analysis. So steady state, by considering Kirchhoff voltage law, current law, we write everything in terms of duty ratio. For example, in the case of a boost converter, V0 is equal to Vs by 1 minus D. This is a steady state equation. We are getting the relation between Vs and Vin. That's it. Input voltage, output voltage related using this equation. I'm telling you, practically, is it correct? No. Practically, it is not correct. Why? A buck converter is concerned. We are neglecting so many terms here. This is a schematic of your buck converter. We neglect everything here. So, what are the terms we are neglecting here? If you look at this very closely, in fact, there is a source resistance. This is called RS. We are neglecting this. Why I am telling you? The voltage available at this point, assume that this is V input. This V input is the sum of voltage of the supply plus drop due to this RS into IS, which is never be constant. This will vary, so that this also will vary. When this varies, this also will vary. When the current is 2 ampere, the voltage is different. The current is 20 ampere, the voltage is different. So this itself we are neglecting. We are assuming that Vin is always equal to Vs. That is a wrong assumption. Second one, the inductor by default offer a resistance. So this is like this. So that resistance we always neglect. And when you talk about a switch is having 3 components. So one is, let me write here, one is forward voltage drop, something like drain to source. If you take any switch, the forward voltage drop across the switch will vary like this. So this is your VDS and this is your current in ID. So there is a forward voltage drop of 0.5 volt. An example, I am telling a typical example, 0.5 volt. According to the current, maybe 20 ampere, it may be more. 20 ampere, it may be more. Accordingly, there is a forward drop voltage, and second one, there is an on-state resistance. Because whenever you turn on the switch, it is like this. So this on-state makes some resistive drop, because every switch, for example, typically speaking, 100 milliohm resistance, it can drop. As an electrical engineer, we may skip 100 milliohm, but assume that there is 10 ampere current flow through this switch. Average current I am speaking. So when you have 10 ampere, the loss due to this alone 100 into 100 milliohm. So 100 milliohm is nothing but 10 watt. So 10 watt loss happen only because of this on-state resistance alone. One element alone I am taking. Then apart from this, there is losses due to switching. So when you take any power electronic switch, the voltage becomes 0 when you turn on, the current become finite when you turn on. This process. So this is your current and this is your voltage, and this point makes some switching losses. So whenever we see how to select switching frequency, that's the biggest question. So you can't generalize that we have to go for high frequency, because when you go for a high frequency, the loss will vary. For example, if you have a converter at a 10 kilohertz or 20 kilohertz or 50 kilohertz, the switching loss always varies. So we have to make some tie break approach to identify this selection of switching frequency according to the power rating, right? So that's what I'm telling you. Such depth analysis we have to perform based on one switch itself. Then I'm coming to the diode. Same like the switch, the diode offers forward voltage drop, on-state resistance, and reverse recovery loss. All these things will be accounted in the case of a diode, and similar to the resistance inductance, there is a parasitic element coming in the capacitor. So what I am telling you, each and every aspect of the converter, practical aspect of the converter has to be considered, and then we have to do the analysis. And finally, whatever the equation you are considering, that is only a 2-mark question, isn't it? So this can help us to get 2 marks in your exam, but not in research, not in research. So we have to understand each and every corner of your DC-DC converter or maybe any converter, and then we have to perform the research. Then only whenever you write a paper to standard publications like IEEE transactions, they will recognize. So simply when you talk about steady state analysis, especially like these, there is no use of that today. You have to look into the each corner of the circuit and then you have to understand. Then whenever you go to the controller, now I am telling you, whenever after doing the steady state analysis, you may see, sir, shall I go to the controller? Assume that this is my control, this is my control, and this is my plant, that plant is your converter, this plant is your converter, and then every converter will have a certain output. Sometimes it may be the current regulation, sometimes maybe your voltage regulation, it depends upon the application. So we sense it, maybe unity feedback we give, and you have your reference here. So by default, this is your reference, we reference, and always we go for a negative feedback system. This is your negative feedback, and this error we feed here. So this is the nature of any closed loop system. So most of the time, whenever we see power electronics, we use either a PI controller or maybe a PID controller. There are 2 constants here. One is called KP, another one is called KI. Whenever you ask our students how they tune the value of KP and KI, they use the term trial and error. So trial and error is not the correct procedure, which is not the engineering language. So kindly speaking, please don't do any trial and error basis. That shows lack of understanding of your system. So properly speaking, you have to go for the dynamic analysis. I'm telling you frankly, most of the power electronics converter does not require a controller even, right? Right? PA controller. I'm speaking PA controller, right? No need of a controller. Why I'm telling you, for example, you take a buck converter as boost converter, the overall transfer function look like this: A into S plus small a whole divided by S plus B into S plus C. This is the transfer function of a typical buck converter I'm speaking. So maybe V0 by Vs. So this is the transfer function of a typical buck converter. I'm telling a final dynamic analysis. You know how to derive the transfer function. You have to write a state space model, then average state space model, then small signal model, then reduction of small signal model, give transfer function. Lot of steps involved in that. By considering time, I'm not going to present those things in detail. So technically speaking, you have to derive the transfer function, significant transfer function. I think V0 by I0, V0 by Vs, and V0 by D. These are the significant transfer function we always perform, because this will be your output variable. This may be your disturbance, load side disturbance. This may be source side disturbance. This is your control signal. You have to understand your transfer function very well. Then only you can go for the controller design. So when you see V0 by Vs, by default, your control system says that your system is stable. Why? Because all the poles are lying in the left hand side. So when you draw a pole zero plot, all the poles will be in the left hand side. There is a zero, everything in the left hand side. So this system is concerned, it is stable in nature. So I'm telling you, when the system is stable, then why do you need a controller? Correct? You need not. You don't need a controller, right? I'm telling you, if you have a feed-forward control, a simple lookup table is more than sufficient to solve this problem. Most of the time when we observe output variation of power in our lab, assume that this is your V0 and this is your time. Your graph is something like this. If it is your steady state output of some level reference voltage, and assume that here you are going to do a step variation. Here you are going to do the step variation. So when you do a step variation, the output may be something like this. Some sluggish response you will get. That's it. So if your application is satisfied with these type of response, your application says that you have some peak overshoot, some raise time, and steady state. If everything is okay with you in that application, what is the necessity of a control? No need of a control. So that's what I'm telling you. Before proceeding to a, you have to do lot of analysis on your controller so that you can pinpoint the direction of research. So hope that it is most useful to you, so that so whenever you go to any control, you are in the position to think about your control system aspect of your power electronics. Technically speaking, if you want to be a master in power electronics or in power system, first of all, we should be a master in control system. So that's what I am recommending. So when you see this buck converter, you have to do significant analysis on the system response. Then only we can go ahead with the proper controller design, or maybe the next step of your converter. So now I am coming to a hybrid energy system. There are a lot of work going on in the hybrid energy system, because one source cannot be used to power our load. So we always depends on more than one source. I already told you, battery with ultra capacitor or fuel cell always makes our system reliable. If one source is not available, immediately we can power up using other source. So like that, lot of research work is going on, and in our case, we do research in DC-DC converter. So rather than integrating every sources using a dedicated DC-DC converter, why don't we propose a monolithic DC-DC converter which can integrate multiple energy sources? That was the research problem what we framed, and accordingly we have proposed. This is a typical PV battery hybrid energy system, you can notice. So this is the present scenario what they have currently. There is a solar panel, there is a battery, and here there is a charge controller, there is a bidirectional DC-DC converter, and load is concerned, there may be a converter here, and there is a motor. So everywhere there are our electronics. So what research problem we have attempted, we have proposed a DC-DC converter which can integrate two input sources and can provide one output load. So this is the schematic diagram of our proposed DC-DC converter, which integrates two input V1 and V2, which produce one output. So this is the converter configuration. We followed a buck boost cell so that it can operate in multiple modes of operation. Input sources can be effectively utilized. In fact, we have reduced component counts so that lower cost and lesser in weight can be achieved. So now you are very clear about what is my research problem and what is the solution I am proposing, what are the features. That's it about quantification of any research. So the proposed converter can be operated in 6 different modes, like a solar powered mode, battery powered mode, parking mode at daytime, parking mode at night time, regenerative braking mode, high speed operation. All different modes are possible using a single converter. A single converter is operated in different way. You can see boost converter, buck converter, super boost converter, like a lot of possible combinations can be achieved with the help of a single DC-DC converter. That is a significant contribution of the proposed DC-DC converter. So these are the different possible modes, as I pointed out, all the possible modes of my DC-DC converter. So in mode 1, particularly in the super boost mode, source 1 charges this inductor, source 2 charges this inductor. Then it discharges through V2 so that higher voltage is achieved with the help of this DC-DC converter. So this voltage equation makes our proposed converter unique in operation compared to the conventional DC-DC converter. So whatever I'm claiming in terms of the research, it is very well proved in my application. So this is my claim. So that claim is well proved in terms of hardware as well as in terms of simulation. So now the advantage of my converter, I claim that using V1 and V2, it can produce the maximum voltage of 5 times that. So that you can see here, the per unit voltage can be significantly improved when the duty ratio increases compared to the conventional DC-DC converter. So when come to the comparison, my claim is component count is reduced. I have made a comparison table. Conventional converter, they use 3 switches, 3 diodes and 1 inductor, 1 capacitor, whereas I am using 2 switches and 2 diodes. So reduction of 1 switch is not a simple thing. Whenever you reduce 1 switch, you are eliminating driver circuit, heat sink, apart from that the control signal. So elimination of 1 switch itself is a major achievement compared to the elimination of 1 diode. So the cruciality is given only to the number of components, especially number of switches compared to number of diodes. That attraction is well proved in terms of loss breakdown. You can see here in the left hand side, the switching loss of the overall converter is significantly reduced compared to the conventional approach. You can see almost half. This is 90 watt, whereas in the proposed converter it is 45 watt. So when the loss is reduced, efficiency can be improved drastically, and when efficiency is improved, size of the converter can be reduced, heat sink can be reduced, lot of cost also reduces. So many advantages we are getting based on the outcome of the research. So whenever you do research, even though the outcome maybe the novelty may be less, but you have to quantify more towards the advantages so that the reviewer will get more attraction towards your paper, so that the possibility of acceptance is more. So finally, we have fabricated our proposed DC-DC converter in the laboratory environment for the given specification, designed specification, and we have observed the hardware results. Here you can see the simulation results and the hardware results are closely matches to each other. And finally, we proved that especially in the hybrid energy system application, rather using individual dedicated DC-DC converter, we can go ahead with our proposed DC-DC converter, so that so many advantages can be claimed. That's the end of that particular research. So in another dimension, I am told that the understanding of the DC-DC converter, I am taking another DC-DC converter. Just I will show, because we have limited time, so that I will skip very quickly. So this is the steady state circuit of the proposed DC-DC converter. I have done analysis of the DC-DC converter in continuous conduction mode, that is CCM. And apart from CCM operation, we are in the position to do DCM analysis. Here you can notice how I have performed discontinuous conduction mode. You can see the current is discontinuous in nature here. So any power electronic converter should be analyzed in the discontinuous conduction mode of inductor to operate the converter in continuous conduction mode. Sometime based on the duty ratio or maybe nature of load, allow the converter to operate in the DCM operation. So though it goes to DCM operation, it is not supposed to be disconnected, so that a clear boundary can be derived between the CCM as well as DCM, so that you can clearly orient the controller to ensure the operation in CCM. Accordingly, you can take necessary steps. So here understanding of the converter in terms of parasitic element we have done. Then I already told how to develop a small signal model. You can see how we develop small signal model. Then from this we derive a significant transfer function. You can see output voltage by input 1, output voltage by input 2, control signal 1, control signal 2, then current, inductor current, all sort of possible transfer functions we have derived, and we have computed the pole zero plot, means Bode plot of each significant transfer function. These help us to infer information about your phase margin, gain margin, more understanding about the converter, so that you can easily design controllers. Here pole zero plot, all sort of analysis we have done. This says the step response of the converter. So step response of the converter shows that initially there is an oscillation. So because of the reactive element of L and C, this is a second order system. You all know the nature of a second order system. So naturally, whenever there is a second order system, there will be a peak overshoot, there will be a delay time, there will be a steady state error. If you are happy with that, you can go ahead with the open loop system. If you want to improve that, you have to go to the closed loop system. Suppose if you want to reduce the peak overshoot, if you want to reduce the steady state error, you have to go ahead with the controller design, so that you can understand more on the system, and also you can design a proper controller. So it's something like a win-win situation. So we have implemented that hardware in our lab, and this is the results what we get in the closed loop system. When there is a step change in load, the voltage is regulated, followed by a small disturbance, so that we have achieved. So that's it about the work we have done, and this paper was published in IEEE Transaction Industrial Application. Same analysis, CCM, DCM, all sort of analysis we have done. So with this, I am coming to the end of today's session. Almost I have covered up whatever I planned. So I extremely thank to the organizer of this FDP. Thank you very much, sir, for giving an opportunity to share some of my research work carried out at NIT Calicut. Now we will move on to the question answer session.
Thank you, sir. Kumaravel sir, it's very nice presentation. Explain it's from basics to advanced research also, and it's give a lot of motivation given to the researchers also, those who are doing PhD and verging to complete PhD. Lot of motivations. Thank you, sir. If having participants, if are having any queries, directly interact with our resource person to unmute your audio. Participants ask the questions. Which one is advanced in PV grid connected system, either single stage or two stage conversion?
The question is not clear. What is the question, sir?
Which one is advantage in PV grid connected system, single stage or two stage conversion?
In the case of grid connected solar PV system, always single stage is going to be an advantage, because efficiency can be improved. At the same time, a compact structure can be achieved. So if you have a necessity of integrating solar PV with battery, always two stages recommended. Because anyhow, if you go for a hybrid energy system, especially support of battery, you need a DC bus. So in the case of a DC bus, the level of voltage of battery and the level of voltage of grid both are in two different extremes. Because battery voltage naturally 12 or 24 volt, sometimes microgrid we follow 48 volt. And whereas if you see AC grid, single phase grid 230 volt, three phase grid 400 volt. If you see the equivalent DC voltage of single phase AC and three phase AC, it will be approximately 350 volt DC and 800 volt DC. So bringing down of 350 volt or 800 volt DC to the battery voltage is very tough in the case of a single stage application. So if you have multi-stage, so that PV can be effectively integrated by connecting maximum number of panels in parallel rather than series, so that effect of partial shading can be avoided, and the hotspot problem due to hotspot can be avoided. So in my point of view, if you concentrate on grid connected solar PV alone, you can go ahead with the single stage. If you go ahead with the battery system, better you can go ahead with the two stage, so that a lot of advantages you can get.
Okay, thank you, sir. Mr. Sivaraj, if you unmute your audio and direct interact with our resource person, Mr. G. Sivaraj is available. Mr. Sivaraj. Mr. Sivaraj, to unmute your audio and direct ask the questions to our resource person. Sir, he posted the question in this chat box. Can you please continue your experience of publication in standard journals like IEEE?
No, what is the question?
Can you please continue your experience of publication in standard journals like IEEE?
It's really a tough question to answer. So my experience will vary from time to time. So as a researcher, we are doing lot of work, maybe for the period of 1 year or maybe 1.5 years, doing lot of analysis and doing hard work and finally drafting 8-page IEEE paper and communicating to IEEE transaction. Sometime your reviewer comments definitely will discourage. Even some of my paper, due to some not strong reason, some of my papers were rejected from IEEE, and by the time and all, I will be much frustrated. Though the paper is from my scholar or my own, we worry a lot because reviewers will never see from our point of view. In front of editors and the forum, they want to get the name. So particularly they will look into your paper detailed manner, and unnecessary questions they will ask. Based on that, they will give rejection. For example, one of my paper, my contribution is on the DC-DC converter novelty. I stated my claim, I proved my claim. But whereas reviewer asked me to do a control design. So first revision, what I have done, I have selected a controller. I have done, I have designed a controller, I implemented a controller, and based on that, I have revised the paper and I submitted after 2 months of time. So now this reviewer have given 22 questions in the first revision. I have answered all the 22 questions, but all the questions are related to control aspect. Some questions related to the converter. So after first revision, again he recommended a major revision with the 26 questions. All the 26 questions are completely irrelevant from the first question. So now you try to understand, my aim is in one direction, but the reviewer questions are pulling me in the other direction. But he is my reviewer, no, I can't neglect him. I have worked a lot again for another 2 months of time, and I have done the all the modifications. And at the end of the second revision, this reviewer again given third revision, and finally editor taken the decision to reject the paper and to resubmit. Fortunately, it was a resubmission, but sometime some of my paper, even after revision, the papers are getting rejected. Highly painful to bear it. As I said, every research paper will come out after a lot of hard work for 1 year or 1.5 years. Then revision 2 months, 4 months, like that it goes. Even after 2 years, if a paper is getting rejected, that is ultimate pain in research. By the time and all, I realized that why do we do research? Better we can leave. That feeling I get sometime. because we get such a frustration that you can understand my feeling. We are drafting a paper, and whenever the papers are getting rejected, I don't have any answer, because redrafting a paper to another journal is the biggest challenge, because already the paper is in IEEE, and if you communicate the paper to another IEEE journal, first question they will ask, have you ever communicated that paper? You can't say no, because that is there already in their database. The moment when you upload the new paper, they will get that your paper is already uploaded in some other journal. If you lie that, sir, I didn't upload any paper, first time uploading your paper, without revision, they will reject the paper, right? So you have to justify properly what are the comments you have received, how you have addressed, everything you have to rewrite again. So that is a highly painful job, but there is no way. As I said, the quality of reviewer is very, very high in the standard journal like that. So you have to bear it, but hope that you can succeed one day, but don't get demotivated. Anywhere it will be succeeded. You should have a patience, and dedicatedly you have to continue work in the particular direction. That's what my experience. I do not know how far this experience fitted to you. It will vary from problem to problem, and maybe journal to journal. Thank you.
Thank you, sir. You discussed your painful experience for publishing research paper. Also, a lot of pain is there. Thank you very much. Mr. Girish Kumar, sir, please say a vote of thanks to our resource person.
One question, sir.
Yes, sir. Yes, sir. Mr. Naresh, ask the question.
Vehicle to grid transmission, which is going to have some fame in the future, sir. What type of converter we are going to use in that concept, sir? Which is good.
Sir, the question is not audible, sir. Could you please repeat?
Yeah. In the concept of vehicle to grid connection, converter plays a key role, sir. What type of converter and which type of the single conversion or double conversion is required? Can you give some idea regarding that, sir?
Yeah, nowadays in vehicle to grid or grid to vehicle application, isolated DC-DC converters are recommended. Second one, fast chargers are coming up. As I said, though we are going to use a massive sized battery, within 30 minutes we are expected to charge. So there will be a huge inrush current. If you try to go ahead with the isolated topology, you will get advantage. If you are going ahead with non-isolated, there are so many risks involved in that, because it can't bear huge transients, which are unavoidable, which cannot be avoided, especially in the fast charging application. So I recommend the isolated DC-DC converter, especially for the V to G and G to V application. Yeah.
Yes, sir. In that concept, we are say if the battery is fully charged, the vehicle is fully charged. I want to connect to the grid. What are the considerations I am going to make over there, sir, to give the energy to the grid?
Sir, calculations.
Yes. Other than SOC, what are the constraints we are going to consider in order to what are the parameters?
I think you can maybe sense apart from the state of charge, you can sense the current regulation as well as the status of grid side voltage. Those feedback also you can consider, so that you can have a smooth transition between vehicle to grid. But that is a dedicated topic. I don't know whether I have answered you depth manner. Sorry.
Yeah. Okay, sir. Thank you. Thanks.
Yeah.
Yes, good afternoon to all. Here is Girish Kumar.
Yeah.
Sir, I'd like to say a vote of thanks to all the participants and the speaker. So, sir, thank you, Kumaravel sir, for your valuable analysis and design methodologies and giving the importance of non-isolated DC-DC converters at PV systems. So the mathematical modeling, what you given, it's most highly important for research point of view, and the research scholars as well as the persons who are writing proposals will be mostly utilize your lecture for their career growth, and as well as the status of PhDs also will grab the opportunities, and they will also acknowledge by selecting the problems related to the DC-DC converters. I very much thank for your great and wonderful session. I thank all the participants for their patience and online listening continuously, and making this session is successful. I thank all the event coordinators for timely organizing the program. Once again, I thank very much for all the participants, and as well as the speaker and coordinators for the today's session. We'll continue the afternoon session. Thank you very much.
So thank you very much, sir, for providing the opportunity. I especially thank Dr. S. Saravanan, sir.
Sir, Kumaravel, sir, thank you, sir. Thank you once again for your wonderful
Thank you,
lecture
sir.
and immediately accepting our invitation also. Thank you very much, sir.
Okay, sir. I wish all the past participants to get a great success in their life. So be a champion in life. Thank you very much once again. Thank you all. Yeah. So you can note down my email ID. You can call me, or maybe you can contact me at any point of time. I will try my level best.
Thank you, sir.
So that shall I leave, sir?